In this video, I'm going to do two applications involving motion and then one involving ratios. So in the first one, I am getting some exercise. I'm walking briskly around the campus, and then I jog 3 times around the loop. So let's say that my walk is fairly brisk, and that is 3 miles an hour, and unfortunately my jog is not very brisk. It's kind of a slow 4 miles per hour. And I'm going to spend a total of 1 hour exercising. So determine the distance of the loop. The loop is, let's see what, since I'm in miles per hour, I'm going to make the assumption that I'm going to come out with miles, but we'll check our units. Okay, so that's what I'm looking to find. Now I need to write an equation for that. They're giving me how much time I'm spending exercising, and so I'm going to write an equation involving time. So time spent walking plus time spent jogging is equal to the total time, and that is 1 hour. So now we need expressions for time walking and time jogging. So the big idea with motion is that distance is equal to rate times time. So if I want an expression for rate, I could divide both sides by t, and if in this case I want to solve for t, I want an expression for time, so I'm going to divide both sides by r, and that gives me that time is equal to the distance divided by the rate. So that's what I'm going to have for each of these. I'm going to have the distance I went divided by my rate for both walking and jogging. Okay, so here we go. The distance that I went walking was 1 loop. And the distance, and that I don't know, that's my x. And then my jogging, I went 3 loops, but I don't know the length of that loop. So I went around 3 times. Okay, so then my time, my expression for time would be the distance. So in this case, x divided by 3, and then here I have 3x divided by 4. So I'm going to put those into my equation. Time spent walking plus time spent jogging is equal to 1. And now I have an equation involving fractions, and so I just look to see what would be the common denominator, and that's what I'm going to multiply everything times, that common denominator. And that allows me to clear fractions. 12 divided by 3 is 4, so I get 4x. 12 divided by 4 is 3. And 3 times 3 would be 9x, and that's equal to 12. Adding those together gives me 13x is equal to 12. And dividing both sides by 13 to solve for x, the loop isn't quite a mile. 12 divided by 3 is about 0.92 miles. And that is about the length of that loop, if you want to go for a walk. Okay, so there it is, 0.92 miles is the length of the loop. Done. In this problem I have ratios. I've got an example with ratios. Now a ratio, the idea with ratios is we're comparing two similar things. Okay, so if we have this, if we look out into the audience in the courtroom and we have all these people, right, there's the courtroom. Some of them are men, right? And then some of them are ladies. Sorry for the sexist representation here. Okay, so in the courtroom, that ratio, the comparison between men and women, is the same as the little jury box, just who gets to go up into the jury box. I don't know if you've ever gone to jury duty, but tons of people are called in, and then they narrow it down and just only have a certain few on the actual jury, okay? But we can set that ratio comparing men to women or women to men. This is going to be a little scary with half a man. Okay, so that ratio is the same. Because when we look at this fraction, we've got 2 women to 4 men. That's the same. That fraction reduces down and is equal to 1 woman to 2 men. So that's the idea. We have fractions that are equivalent. with ratios. So looking at this problem, in the jury there are 8 more women than men if the ratio of men to women is 8 to 7. Okay, that sentence right there is letting me know how to set up my equation. The ratio of men to women. So I'm going to be comparing men to women in the jury pool and then also in the actual jury itself. Okay, so men to women. What comes first is the numerator, so that is men is 8, women is 7. Determine the number of men and women in the actual pool. Okay, so I need to set this up so that I'm comparing the same thing. So men is numerator, women is denominator in this particular question. The jury pool, there are 8 more men than women. So if we let X be the number of women, then we need more men, right? There's 8 more than the women, so X plus 8. Okay, and then we're comparing men, so that's X plus 8, to women, which is X. All right, and there we have it. So we have a fraction equal to a fraction, so we set cross products equal. 8x is equal to 7 times x plus 8. And now we can solve our equation. 8x equals 7x plus 56, giving us x equals 56. So there are 56 women in the pool, and then for the men we need to take that 56 and add 8. So we've got 64 men, and there's our total. Okay, in a work rate example, we can set this up as the amount done by the first person or the pump or whatever we're comparing plus the amount done by the second one is equal to 1 completed job. And in these, the amount done is really, it is given by this idea of distance equals rate times time, but the distance we're looking at is kind of like the distance through the job. How much of the job have you completed? And then we would take that times the rate times time. So the equation that we get to use is x over m plus x over n equals 1, where x is the time needed together, and m and n are how much time it takes them to do the job separately. Because if we had rate times time, well, the rate it takes, they do one job in m hours, that's the rate of the first person, times time, which is x, plus one job in n hours, that's the rate of the second person, times x, and then you multiply those fractions to get one completed job. Okay, so that's where that formula comes from. All right, so let's go ahead and use it. So we have Joe painting the deck in 5 hours. And Joe and Grace can paint the deck together in 2 hours. So the numerator is the time it takes working together. And how long will it take Grace? That's the thing we need to know, is the number of hours for her working alone. And together they get one job done. Okay, so this is actually an example of a rational equation with this variable down in the denominator, but we solve it just the same as any equation involving variables. We're going to clear fractions. Okay, so what we're going to do is multiply everything by the common denominator, which is 5n. All right, so we clear fractions, and then we get 5 divided by 5 is 1, so you've got 2n plus n divided by n is 1. 5 times 2 is 10, is equal to 5n, and then we just go through and we can solve this. So we get 10 is equal to 3n. Okay, which gives us, here if we divide both sides by 3, we would get n is equal to 10 thirds, and so that is 3 1/3. So it would take Grace 3 hours and 20 minutes. What's a third? Equals 20 minutes. Okay, so this would be 3 hours and 20 minutes to do the deck by yourself.